Hello all, today we will be learning about k-means clustering in data warehousing and data mining. I am using Google Collaborative over here, so I have mounted my Google Drive to access the dataset. So this is the code to mount the drive in Google Collaborative, and here I have imported all the necessary libraries. Here we read the CSV using this code, and this is my CSV over here. It has various columns depicting the properties, and we have 149 entities here. So the basic idea in k-means clustering is that we have to form clusters, and here we will be using this dataset. This is iris dataset. Now let's learn about k-means clustering. So what is k-means clustering? K-means clustering is an unsupervised learning algorithm which groups the unlabeled datasets into different clusters, where K defines the number of predefined clusters that need to be created. In short, K is the number of clusters that we create. As if K equal to 2, there will be 2 clusters, and similarly for K equal to 3, we will be having 3 clusters. It is an iterative algorithm that divides the unlabeled dataset into K different clusters in such a way that the dataset belongs only one group that has similar properties. Now let's learn about how exactly it is done. It allows us to cluster the data into different groups and a convenient way to discover the categories of groups in the unlabeled dataset on its own without the need for any training. It is a centroid based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of distances between the data point and their corresponding clusters. So we will be using the concept of centroid. What is centroid? We have a center value associated with each cluster, and based on these centroids, we will group up the other data points. Now let's learn about the working of k-means clustering. So this is the working algorithm for k-means clustering. So the first step is to select the number k to decide the number of clusters. Then the second step is select random k points or centroids. The third step is to assign each data point to the closest centroid. The fourth step is to calculate the variance and place a new centroid of each cluster. Fifth step is repeat the third step, which means reassign each data point to the new closest centroid of each cluster. If any reassignment occurs, then go to step 4, else go to finish. The model is ready. So how do we know which data point belongs to which cluster? So we will assign a centroid, and then to know which data point belongs to which cluster, we will use Euclidean distance. The distance we are finding is between the observed value and the centroid value. Now what is observed value? All the other values other than centroid value will work as observed value. And once we have calculated the Euclidean distance, we analyze the values obtained, and the smallest value Euclidean distance will decide which cluster the data point belongs to. Once a data point is added into the cluster, we need to calculate a new centroid. After entry of each new data point, we are supposed to recompute the centroid's value. And once we update the centroid, we again reassign each data point with respect to the new closest centroid of each cluster. And similarly, we have to calculate a centroid at each step, as at every step a data point will enter a cluster, and as the data point enters the cluster, we will find the centroid of that cluster, and using the new centroid, we evaluate the next centroid using Euclidean distance. Now let's understand this using a pictorial representation. So here initially we can see we have a dispersed data set, and here we can form three clusters. So now according to step 1, we now know the value of k, that is 3. Now according to step 2, we will select 3 centroids in our case. So these are the 3 centroids that we have selected. Now according to step 3, we assign each data point to their closest centroid. Now this we do using Euclidean distance. The data point closest to the centroid will be assigned to that cluster. And once a data point is added into the cluster, we calculate the variance and place a new centroid of each cluster. And then according to the algorithm, we repeat the third step, which means we reassign each data point to the new closest centroid of each cluster. This is how we assign the data points to its closest centroid. And then we compute and place the new centroid of each cluster. And as a new data point is added into the cluster, we reassign each data point to the closest centroid. If any reassignment takes place, we go to the step 4, else we finish. Now as we know that K-means clustering is an unsupervised learning algorithm, let's learn the difference between the supervised and unsupervised learning algorithm. The supervised learning algorithms are trained using labeled data, while the unsupervised learning algorithms are trained using unlabeled data. The supervised learning model takes direct feedback to check if predicting is correct or not, while the unsupervised learning model does not take any feedback. The supervised learning model predicts the output, while the unsupervised learning model finds the hidden pattern in the data. In supervised learning, input data provided to the model along with the output, while in unsupervised learning, only input data is provided to the model. Supervised learning needs supervision to train the model, while unsupervised learning does not need any supervision to train the model. Now let's get back to the program part. We extract the independent variables and then we find the optimal number of clusters using the elbow method. Now from the sklearn.cluster we import the k-means and then initialize the list for values of WCSS. Then using a for loop for iterations from 1 to 10, we use this for loop and execute this piece of code, and then using the plotting functions we plot a elbow method graph. Then we train the k-means model on the dataset that we have. Now finally we visualize the clusters, and using the plt.scatter we plot three different clusters having three different colors so that it becomes easier to identify the clusters. And now using these plotting functions we plot the graph, and this is the obtained output by using k-means clustering upon the dataset. Now let's see what we mean by elbow method. The elbow method is one of the most popular ways to find the optimal number of clusters. It uses the concept of WCSS value. Now what is WCSS value? It is within cluster sum of squares, which defines the total variations within the cluster. Now the formula to calculate WCSS is as follows. Now what does summation of pi in cluster 1 distance pi c1 whole square means? It means that it is the sum of the square of distance between each data point and its centroid within a cluster 1, and the same for other two terms. As we can see over here, we have the same term for second cluster and the third cluster as well. Now to find the optimal value of clusters, the elbow method follows the below steps. It executes the k-means clustering on a given dataset for different k values that ranges from 1 to 10. For each value of k, we calculate the WCSS value, and then we plot a curve between calculated WCSS value and the number of clusters k. The sharp point of bend or a point of the plot looks like an arm. Then that point is considered as the best value of k. As we can see over here, this graph looks like an arm, and hence it is called as elbow method. This graph is plotted on the basis of number of clusters and WCSS value. Here we obtain the optimal number of clusters. So this is it about k-means clustering. Thank you.